Hello everyone, my name is Vedasri Pulpatti and this is my final project presentation for my internship at Iot Information Technology Private Limited. My project is titled Iot Based Home Automation using Arduino and Blink app. In this presentation, I will explain what I learned during my internship, the objectives and working of my project, the components and tools I used, and finally I will demonstrate the simulation of my system in PixSimLab connected to the Blink IoT platform. This internship was conducted at Iot Information Technologies Private Limited, which is one of the India's top training and development centers for embedded systems and IoT. During my internship, I was introduced to the world of embedded development and how hardware and software come together to create intelligent systems. The training covered embedded C programming, microcontroller basics, Arduino development, and IoT integration. I learned how to connect physical sensors to controllers, process the data, and visualize it using IoT platforms. The internship helped me move from basic coding concepts to real-world embedded applications, preparing me for industry-level IoT projects. One of the most valuable parts of this internship was learning embedded C programming. I learned how to write efficient code that interacts with sensors and actuators. I also explored the Arduino IDE and board configuration, understanding pin mapping and serial communication. The training included practical exercises on reading analog and digital sensor values and controlling devices like LEDs and motors. Then I was introduced to IoT concepts, especially how microcontrollers communicate with cloud servers. Lastly, I learned to use the PixSim simulator, which allowed me to test my circuits and code virtually without any physical hardware. My project focuses on simulating a smart home automation system where users can monitor and control devices remotely. The system is built using Arduino Uno, simulated in PixSimLab and connected to the Blink mobile app. The main goal of this project is to provide a user with an intelligent home system where lights turn automatically based on sunlight. In gardens, temperature is maintained automatically and the water tank is monitored and managed efficiently. The communication between the simulated hardware and the mobile app is done via Blink IoT app, which acts as the bridge between the controller and user interface. The entire setup is virtual, so all devices like LEDs, sensors, and valves are simulated, but it behaves exactly as a real-world IoT system. The main problem addressed in this project is the lack of automation in regular home systems. Most appliances still require manual control, leading the unnecessary energy usage and inconvenience for us. To solve this, the project objectives were defined. First, to automate light control based on sunlight using a LDR sensor. Second, to manage home temperature using LM35 sensor, heater and cooler. And third, the last one, to automate the inflow and outflow of water in a tank. Finally, to make the system user friendly and control and monitoring functions are integrated in the Blink IoT app. For this project, I used several components, all simulated using PixSimLab platform. The Arduino IDE is used for coding. The Arduino Uno serves as the brain of the system. The LDR sensor detects ambient light to control garden lights. The LM35 sensor reads the surrounding temperature, helping in controlling the heater and cooler. LEDs are used to represent light, while simulated valves represent in the inlet and outlet of the water tank. The LCD module displays temperature, water level, and status messages such as heater on or water level full. The Blink mobile app acts as the control interface. User can operate all systems directly from their phone and receive notification about any status changes. The block diagram represents the overall system architecture in simple form. Sensors like LDR, LM35 continuously send input data to the Arduino. The Arduino processes these signals, makes decision based on conditions, and sends the result to the Blink IoT platform. The Blink IoT app then updates its bits accordingly, giving the user real-time control and feedback. Simultaneously, the LCD display provides local updates. For example, when the heater turns off automatically due to high temperature, both the app and LCD display the status change. The system is divided into 3 functional modules. The first module is garden light control, where the LDR sensor detects sunlight and adjusts the LCD brightness accordingly to the sunlight. The second module is the temperature control, which includes LM35 sensor, heater and cooler. The Arduino reads the temperature and either activates or deactivates the heater and cooler automatically. The third module is the water tank system, which monitors the volume and manages inlet and outlet valves. When the tank is full, the inlet valve closes automatically and a message is sent to the Blink app. Similarly, when the temperature exceeds 35 degrees Celsius, the heater turns off automatically with a warning notification. The Blink IoT app plays a crucial role in the interaction. The dashboard contains several button widths to manually operate the heater, cooler and valves, gauge widths to display live temperature and water levels, and terminal widths to display system notifications like temperature exceeded or water level full. These features make the project fully interactive and close to the real-world IoT solution. This is the code for our project. Here we can see the Blink template ID and device name and the authentication token, which I have created my Blink app and set them all for the project. This is the main code, and we can see the call of functions for the temperature system, LDR, serial tank, etc. And we have divided the codes in the other tabs. Here this is LDR code, where we use the LDR sensor and control the garden lights. And next we have the main.h. Here the pins are represented, and here serial tank code, for which we will control the inlet and outlet of the water, and when it is filled we know. And here there is a temperature system. Temperature system code is for controlling the temperature. The cooler and heater also contains in that. Here we can see the code. Now we are compiling it. This is the code written for the project. After compiling, we export compile binary code. And now we are going to the PixSim lab, and we will open the setup we made in the PixSim lab. Going to the spare parts. The spare parts contains the CLCD, temperature system, and consists of heater, cooler, as we know. And here there is the Ethernet shield and LDR. Here there are LED lights. And we will open the serial remote tank. Here we are using COM1 port because we used COM2 port for the PixSim lab, and we connect both COM1 and COM2 here. Connecting both COM1 and COM2. Here it is already connected. Serial remote tank and the PixSim lab are connected. And now we are loading the code to the Arduino. Let me show the interface of the Blink IoT app. Here it is connecting with the desktop. It is connected. This is the Blink IoT app we are using for our project. Now we opened it. The tab 1 for the temperature and tab 2 for the serial tank. Control have one user for heater and cooler. There is the temperature gauge which measures the temperature, and terminal which node faces controller. Now let's see what is the area sensor. What does it do? If resistance is low, it means intensity is high. There will be no light blinking. If resistance is high, there will be the light blinking, because if less intensity, this is the temperature system. And now let's see how our project works. When we turn on heater, there will be the increase of temperature. We can see that here by CLCD, and also temperature sensor. We see the temperature increases, then 35 degrees, the heater will turn off. See this in the Blink app, the heater turns off. Now coming to the cooler. Switching on the cooler at temperature automatically decreases. We can see that there is the CLCD here, the temperature decreasing. A Blink IoT app, the notification is popped up. Now coming to the cereal tank, which we are doing in the tag 2. This is the cereal tank using PiximLab. Now we are turning on the outlet valve. When we turn on outlet valve, we can see the water volume decreasing, the CLCD, and also in the mobile app. As I already mentioned that when the water volume is less than 2000, then the inlet valve automatically turns on, and we can see the water volume is stable, and we turn off the outlet valve, and we can observe the water volume is increasing here, the Blink app, and recall. We can also observe it in the CLCD, where the volume touches 3000, the inlet valve turns off automatically as mentioned before. Here we can observe that in the Blink app notification, terminal water inflow disabled, water level is full. Water inflows enabled, such type of notifications are visible. In the terminal, we can observe them. This is the output of my project, where we can observe the 3 main objectives: LDRs and temperature control, cereal tank, and this is my output. Now I am concluding the project. This project successfully demonstrates smart home automation in simulation combining IoT, embedded systems, and mobile control. I have successfully completed and tested all modules of my project in the simulation. The system integrates sensors, readings, device control, real-time monitoring, and IoT-based interaction. This project helped me apply my theoretical knowledge of sensors, microcontrollers, and communication systems into practical environment. It gave me deeper understanding of embedded systems, IoT, and real-time data communication between devices and cloud platforms. This internship also strengthened my programming skills, logical thinking, and problem-solving abilities. I could like to take this opportunity to sincerely thank Amertex Information Technologies Private Limited for providing me this internship opportunity and for guiding me throughout the project. I am especially grateful for my mentor and instructor who provided continuous support. valuable feedback and technical guidance during my learning process. Finally, I could like to thank all of you for taking the time to watch my presentation and project demonstration. I hope you enjoyed learning about my IoT based home automation project. Thank you very much. Thank you.